ratio test problem, and let's quickly dive into it. So let me name my page ratio test. Give me the question and let's see what we are supposed to do there.
Okay, so it's 2.
Which paper is that?
Hey?
Which paper is that? The year?
I think it's a 2022 paper.
2022.
Question 3.
And then let's look at question 3. So what did they give you?
So they gave you, it said use the ratio test to determine whether the series converges or diverges. And then the thing they gave was 2 to the power n plus 1.
2 to the power of n plus 1.
Divided by
n
times
n
3 to the power n minus 1.
3 to the power of n minus 1, like that.
Yeah, just they didn't put brackets, they just put a dot for the multiplication at the bottom.
Okay,
But, yeah,
no problem. Let's use a bracket. So the ratio test, all what it says is we are looking for L, which will be the limit as n approaches infinity of an plus 1 divided by an. That's what the ratio test is saying. So anyone please remind me, when the L is less than 0, not less than 0, sorry, less than 1, is our series converging or diverging? Anyone?
It's converging.
Converging, easy. And then when the L is greater than 1, our series is diverging. And then what happens when L is equal to 1?
Inconclusive.
Inconclusive. On point. So let's proceed then. Since we are given our an, we need to find our an plus 1. So we're given the an. Let's go ahead and find an plus 1. So our an plus 1 will be, wherever we see n on the formula, for an will put n plus 1. So which means we'll have 2, n plus 1 plus 1. There we had n, then divided by, we had n, so we'll put in n plus 1, and then open bracket with 3, where we see n, we'll put n plus 1 minus 1. Okay, gentlemen who posed the question, are you still following?
Yeah, I'm following.
Okay. So if you look at the numerator, we'll have n plus 2 divided by n plus 1, and then this will be multiplied by 3 to the power of, if you look carefully, this one and this one will subtract to a 0, so we'll be left with 3 to the n. And then what you want to do is to have the same kind of equation. So what I'll do here, I'll go back to my an and have 2 to the n times 2 to the 1 divided by n into 3 to the n times 3 to the minus 1. So I would like to keep my equation as such. Okay, helps me a lot. So which means even with this one, what I'm supposed to do is I'm supposed to have my 2 to the n multiplied by 2 to the 2. Then the denominator, there's no splitting which I can do. So it will come back as it is. So now that I have this, I can do my L and divide the 2. So I will zoom in. Let me make some space before I do that. Make some space. So my L will be the limit as n approaches infinity. Our an plus 1, we now have it, which is 2 to the n times 2 to the 2, all divided by n plus 1, multiplied by 3 to the n. And then we are dividing by an. So when I divide, allow me to multiply, but flip the numerator and the denominator. So which means I will have n, 3 to the n times 3 to the minus 1, divided by 2 to the n times 2 to the 1. Do you still understand what I did?
Yes, sir, I understand.
So there's terms which are going to come. N, then it's P, F, L will be then approach of now left the 2, and then divided by, we have n plus 1, and then we are multiplying by n, 3 to the minus 1, divided by 2 to the 1. So I can try and simplify these a bit, collect those numbers and factor them out. So if you look carefully, limit as n approaches infinity, I have 2, I have that, one of it will cancel with that, and then we'll have 2 to the 1. So when you look carefully, we have 2 multiplied by 3 to the negative 1, that just becomes 2 over 3, multiplied by n over n plus 1. And when I'm taking the limit, I can see that my limit as n approaches infinity, I will have my 2 over 3, I can put it outside and then evaluate n over n plus 1. When I put in my infinity there, it will be infinity over infinity. But there's no need for us to even go and use L'Hopital's rule. We can do a very smart way and multiply by 1 over n, then divide by the multiplication of 1 over n again. So even the denominator will multiply by 1 over n. If you look carefully, our limit as n approaches infinity of 2 over 3, it will be, this will cancel that, so that we have a 1 on the numerator, divided by, this will cancel that, such that we have a 1 plus 1 over n. Now we can put in our infinity. So if you look carefully, we'll have 2 over 3, and then this will be multiplying 1 over 1 plus. So the limit now applies where there is n. So we have the limit as n approaches infinity of 1 over n. So what is this part equal to? We have the limit as n approaches infinity of 1 over n. What is it equal to? Anyone in the meeting?
0.
0 point. So if you look carefully, we have the absolute value of 1. So our L is 2 over 3. And as you can see, 2 over 3 is less than 1. So this means our series, or the series, the series which you were given, as it goes to infinity, if I remember, it is 2 to the n, divided by n, 3, n minus 1. There's a plus 1 there. Yes. So that series converges according to the ratio test. Any questions? Anyone who has a question, this converges according to the ratio test because our L is less than 1, as you can see here. Our L is less than 1. 2/3 is less than 1. The person who posed the question, are you answered?
Yes, I'm answered. Thank you, sir.
Okay. Any other questions?